Now, our sun has multiple layers to it. It is not the same from the inside to the outside. If you go from the inside out, the major layers are the core, a big area which is known as the radiative zone or the radiation zone. There is a conductive zone. This illustration says convective zone, and they basically are the same thing. I will explain later. An area called the photosphere. The photosphere is actually what we see if you took a photograph of the sun. You would be taking a photograph of the photosphere. There is the chromosphere. Chromosphere is a colored outer layer of the sun that is very difficult to detect unless there is a solar eclipse occurring. And then there is a large halo-y area around the sun, which is known as the corona. So we're going to talk about each one of these layers because it tells us so much about our star. It is important that you know which layer is where in the sun. Here are a couple little memory aids, mnemonic devices to help you memorize the layers of the sun. I don't know which one is going to speak to you, but here are some of them. So, can Randy come play Chinese checkers? For core, radiative zone, conductive zone or convective zone, photosphere, chromosphere, corona. Corny rodents can photograph colored crowns. And crazy rappers can purchase crack cocaine. I actually had students come up with all of these in the past. So if you come up with one that's better, you let me know because I'm always looking for a better way to help people memorize this stuff. The centermost part of our star is called the core. When we start talking about nuclear fusion, this is the area where the heat and the light is actually produced. It is about a quarter, about 25% of the solar radii is actually the core. So about 25% of the whole sun is made of this core. It is the hottest place in the solar system. There is no place as hot as the actual core of our star. It's about 15 million degrees Celsius. At that point, the difference between Fahrenheit and Celsius really doesn't matter that much. It's just really, really hot. And that's where the nuclear furnace is that produces all the heat and all the light that actually allows for life on planet Earth. Outside of the core, there is an area that is known as the radiative zone. Now, the radiative zone makes up about 70% of the sun's radius. It is a large section of the star. This is how heat moves outward, and it moves outward from the core to the outer regions of the star via radiation, hence the reason it's called radiative zone. Now, when we say radiation, when astronomers say radiation, they're referring to electromagnetic radiation. Basically, they mean photons of light. What kind of light? Because you know there's ultraviolet, infrared, visible, X-ray gamma rays, and the honest truth is just about all different types of electromagnetic radiation are produced and come through that radiative zone. Now, a photon is produced in the core, and it has to get through the radiative zone out to the point where it can actually get to the outer edge of the star. The problem is that in this middle of a star, it is nutty, crazy hot, insanely hot. So it's 15 million Kelvin in the middle, and it's down to about 1/10 of that on the outside edge, 1.5 million Kelvin, 1/10 the heat temperature. As a photon comes out of the core, it starts a process known as the random walk. So this little photon is trying to get to the surface, and it gets hit by another photon. And it goes back, and it goes this way, and it gets hit by another photon. It goes that way, and it goes this way, and it gets hit by another photon. Because the gases in that plasma that makes up our star is very, very dense. There are so many particles packed so closely together that this poor little photon, as it's trying to make its way to the outside layer of the sun, it keeps getting hit and bounced back and hit and bounced back like a billiard ball falling off or hitting or bouncing off of the edge of a pool table. On average, it's going to take over 170,000 years for one photon, one little piece of light, to go from the core to the outside of the sun. Due to these random collisions, it can take up to 1,000,000 years. 1,000,000 years. That is a nutty long period of time. So if you see light that actually comes to our eyes here on planet Earth, yes, it took 8 minutes to get from the sun to the Earth, but those little photons of light may have taken 1,000,000 years to get from the core outward. It is a crazy, insane place in the center of the star. After the radiative zone, there is an area that is called the convective zone. Some people call it convective zone. Some people call it conductive zone. We're going to stick with convective zone. That's more accurate. What happens there is heat actually moves from the radiative zone to the outside of the star via a process called convection currents. Convection currents only happen in fluids. You are familiar with convection currents in a water pot. If you get a pot of water on the stove boiling to the point where it has a rolling boil, you have produced convection currents. Here's how this works. The water near the bottom of the pot gets hot. As it gets hot, it rises. As it gets to the surface, it's going to cool down and it's going to fall. You know from life experience that hot gases rise like in a hot air balloon and cold gases fall. This circular pattern of hot gases rising, cold gases falling, or hot fluids rising and cold fluids falling is called a convection current. We see it on the stove when you boil a pot of potatoes. This is how most home heating systems work. They put the radiator on one side of the room and let the heat go. Or if you have a house, they put the furnace in the basement, let the hot air rise and the cold air return, brings it back the other direction. And so the heating system uses natural convection currents to move the heat around. Inside of our star, when the heat gets out of the radiative zone and gets in this outer zone called the convective zone, the hot plasma rises, gets to the surface of the sun, cools, and comes back. And this whole process creates these circular convection currents on the surface of our star. The next layer is called the photosphere. Now, if you would take a photograph of the sun, what you would be taking a picture of is the photosphere. This is the part of the sun that we see. In Old Greek, photos means light. And the sun has gone from 15 million Kelvin in the center core of the sun, that hottest place in the universe. By the time it gets out to the photosphere, it's down to 5,800 Kelvin. Much, 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 much cooler. Still insanely hot, but not as nutty hot as the center of the star. Now, I just want to make sure I'm going to stop, I think, right here. Okay, sorry about waffling a little bit there. We are going to do the rest of the layers of the sun in another video, but I'm going to throw some other stuff in between. So we'll see you in a bit.